Hi, welcome to another video and episode on my Arduino Mega2560 using pulse width modulation with several electronic components, including a motor with propeller, chain with a switch, and several LEDs. Also RC, no, there were RC circuits, there are now RL circuits only. In order to understand or try to understand why several electrical effects don't act up or don't occur or come close to what I want, I set up this simulation. However, this simulation is not exactly what I want, because this one goes from an AC source, and the Arduino doesn't deliver AC, it delivers a DC. So I have to change this setup, and in order to achieve that, I will adapt this circuit, and what I need to do first is replace this, and I need to replace it with this block, which should be possible, but now there is a problem, because this is not a original Xcos, this is a variable resistor from Scilab, so I need to add the same source. And let's see if I can find just that. And this is source nonlinear continuous. No. Why are they collapsing each time? I don't know. It would be very nice if Scilab had at least one of those blocks. Here you find the variable resistor that I got from Scilab, and it would be very nice. And actuators and pre-actuators aren't there either. So this is giving me a slight problem, because what I had in mind is this one, with the pulse generator going here. Let me get back to electrical, then a constant voltage which goes right here, and the ground being right there. This will be the best way to do it. However, I cannot connect this, so I need to find a way to overcome this, and as you can see, Scilab doesn't have that. So how can I bridge this? Can I bridge it? Apparently it can. That will be very nice. So let's save this as version 2. However, not DC, AC but DC. So let's say alright. Could not save program. Oh, that's a very nice one. Why can't you save that? let's just select Xcos. No, I'm in the wrong directory, so that's a very good one. I have to go up here and then go to Documents, and in here I can save it. There you go. So this is what I want, and now I can run the demonstration. I ignore this one, and there you go. So this gives a very nice block diagram. By the way, it is centered around -5, and I don't like that, so I'll have to change that. Let's first stop the simulation and see how that can be adjusted. I've been looking throughout this web browser as well as internet, and I can't find a way to change the value on the fly other than this sinusoid or block or trapezium or whatever. So I decide to remove these and go for a constant resistor, which is right here. It is no problem at all. So now I have to set this resistor, and then I have to look at the actual circuit, which has, for now, when I replace the potentiometer by a resistor, it is just 1, but I can turn it up and down. So let's for now say 343 ohms. Then let's just save it and run it and change the value and see what happens. And 343 is actually 2 of the resistors I'm using in series. So let's just see what happens. Yes, I ignore that. So this is with 343 ohms and like this pulse generator on DC. Then let's do one at 686, which would actually be 4 resistors. Save and run. It should be changed somehow, but I don't see a change. And that is all because usually with a change or with a varying number of resistors, i.e. using a potentiometer, you should be able to see difference. So the question is, why don't I see one? Let me look at this one. It says 0 volts. I have to change this to 5 volts. That's for one. because the output of the Arduino I'm using is 5 volts. So let's see what this is. Pulse width of 20, periods is 10, amplitude is 7. Let's bring that down to 5. This is more likely. So with that result, let's see what happens. Now this is not what I want to see, because I wanted to see around 5. So how should I do it? Of course I can't change this. However, I can change this. Or can I? No, I can't change this either. Okay, this is not changeable. Not either. It would be nice if I had some offset to say, to set, so I can say, okay, start at 0 volts. But other than this, there's nothing to set, so that is unfortunate. What I may check is amplitude of negative amplitude. I don't think so. Let's just check and test. Look at that. A negative amplitude. So that is something I did not expect. Let's continue on doing this. So now we have this value with a negative amplitude, but let's play a little bit with the circuit. Move this to the right, this one as well, because the circuit actually has an inductor part. Oops, I only have to change this. Then go to the palette, find the inductor, now how can I set? This is a very little one. I have no clue what the actual inductor is, so let me have a little look. It says something like 20, so let me add a 2 in here and see what happens. And let's not forget to save and then run. Yes. There's hardly any difference. So since that is not to change, let's change the values to just 1, and 1 was about 181 ohm. Let's see if that changes anything. Not. Okay, not that I can see anyway. So the real change is in here with a pulse width and a period. Let's see how that works. Yes. That is a big change, but I've changed two at the same time, and yes, the 90 is quite obvious, and the 20 is very fast, so let's go to 5. And this is a remarkable change. So let's review. I changed the period to 5. That is well noticeable. So the period is 5, but the pulse width is 90. So if I change the pulse width to, for example, 40, what will happen? This will happen. So now you can see that this is a genuine block wave, and the question is this really resembling a circuit on the Arduino? Yes, I have this, yes, I have this, but these values are not really influencing what I see on the scope. This value is, and of course this value is too. So I'll have to see how genuine. To try to resemble the actual situation a little bit, I have tried to add from the Scilab palette several components, and those exist of a DC motor, speed sensor, and just a block that converts this output to input for the scope. However, I'm not ready yet. I still need some input for this block, so I'll put this in here, and then let's see if I can connect this here. Oops. And see if this runs. So let's save this and have an experience. And this looks like an oops. During block parameters update, a failure. So, which is the failure? I honestly can't say. Maybe that it needs a source block, but that's from here. And this will no doubt give an error on the block. Yes, it doesn't accept a loose end. So what else can I do? An electrical source. I could put an electrical source to it from here, so but I do need a DC current. Pulse voltage, trapezoid, sawtooth, sine voltage. constant voltage, I'm fine. So let me do this, and then I need a ground, and I have a ground here, so let me connect this as well. What voltage do I want? 5 volts, constant voltage. Let's see how this works out. And oops. And again a failure. So with this failure, I am not quite sure how to do this. It's mixing up. It says it's model. It's, yeah, something runs and at the same time it fails. So I think this is something I need to find out, but I would like to have the motor running anyway. So although this is a nice view, maybe it's too much for now. At the same time, the circuit is running, not with the voltages, because I haven't obviously now checked every voltage, but those are the same because the circuits haven't changed, and I need to find out more about this. Can I do more? Right now, I don't think so. So this is it for this episode. More to come, of course. If you haven't yet subscribed to my videos but like to, please do so. If you like my videos or this video, you can support my blog and videos by allowing advertisements in between the video segments. If you don't want to do that, please visit my website, which is listed under this video, for more information about another way to support me, and my website and my videos, of course. And this is to be continued. And let me go back to some other things, because I do want to have a nice block generation. So I will remove these for now. Run. And it says again an update, a problem. So there's something I probably have to reset Scilab. Anyway, that's it. And as a very short ending, I did restart Scilab and loaded the circuit you saw and ran it. So let's hope it starts again, and there it goes. So it is indeed a problem that I noticed before. When you run things for a longer time and restart, Scilab tends to not exactly work properly. Reloading everything works. And what you can notice is that this side is of course represented on top, and you can see that that those are not exactly straight lines. And this motor is of course the nicest to see, with overshoot, undershoot, and this is just very nice to see. Does this resemble my circuit? A little bit better. It has two motors, actually three independent circuits. So with pot meters, so this doesn't really count, but the voltage is okay. It's 5 volts, this is 5 volts. It kind of works, and this is really the end.